Hello everyone. Today I'm going to be talking about Lab 1 for Physics 2212, which deals with charged clear tape. The overall goal for this lab was to overcome the transfer of electrons. This transfer occurred when a piece of clear tape is pulled off of another tape, creating a charge, and a second piece is also done creating a charge in the same way. So during this lab, those two pieces of same likely charged tapes, in this case they were negative, were placed up together like in the figure above, and tape B kind of levitated over tape A. And so we'll explain why that happens a little bit later. But after this transfer of electrons, the student also needs to calculate the charge of the tape as well as the ratio of electrons to atoms. So to do this, we need to utilize the Coulomb's law, which relates the force of an electric field to the charges and the distance between the particles, as well as the momentum principle. So this lab resulted in a piece of charged tape for me that had a charge of negative 5.6 times 10 to the negative 9th coulombs and a ratio of 7 times 10 to the negative 8 electrons per atom. This table here shows all the data that was collected from the lab, with all the given or measured data on the left-hand side and all the actually calculated data on the right-hand side. So now to get into the math and the process. So to find the distance between the two tapes, 3 trials were taken, and we received a distance of 1.2 centimeters separating the tape right before it, or during its levitation phase. We were able to determine that this tape was negatively charged because a pen, which was negatively charged, was repelling the tape. So the mass of the tape was calculated in kilograms. That way the gravitational force could be calculated, and this was negative 0.00196 newtons. And using the momentum principle, we can conclude that the electric force is going to be the same but positive of that, as 0.00196 newtons. This is because since the object is not in motion, that it's motionless, the two forces acting on it have to result in a net force of 0. So using the Coulomb's law, we were able to create or calculate the charge of the tape. So for me, I got negative 5.6 times 10 to the negative 9th coulombs, like I stated earlier. And this charge helped us calculate the number of electrons on this piece of tape, which was 3.5 times 10 to the 10th electrons. Using the principles of surface area, we were able to calculate the number of atoms on that piece of tape, which resulted in 5 times 10 to the 17th atoms. And with these two values, the number of electrons and the number of atoms in this tape, we're able to create a ratio, which is 7 times 10 to the negative 8 electrons per atom. So to kind of model up this lab, make it visual, we created GlowScript code for you guys. So here we have 2 pieces of tape. We're using the point charge system, and we're assuming they're point charges here, and that's what those 2 blue balls are representing. They're blue because those tapes were negatively charged. So we have the green arrow, which represents the gravitational force, and we have the orange arrow, which represents the electric field force. And so if you notice these 2 are equal, again, momentum principle, there's a net charge of 0 on that top charge. So there's some things that we assumed in this lab to be true. We assumed there was no air resistance. Again, we assumed that they're point charges. We assumed that the U-tape both U-tapes had the same amount of charge, and that the charge was evenly distributed along the tape. Without these assumptions, the calculations that we got would not have been possible. There would have been several little other calculations we would have had to do. So that concludes the end of Lab 1 for Physics 2212. Thank you very much.